Hello, everybody. My name is Yancheng Lu. I am a bachelor student from the University of Liverpool. Today, I'm going to present my essay, which the title is A Novel Approach to Breast Cancer, RF16662's Potential. The presentation today will be split up into three parts. Firstly, I am going to discuss about the challenges that we are facing recently when treating breast cancer and the significance of the new compound RF16662. And then I am going to discuss the method used to evaluate the effectiveness of this compound. And finally, I will reach into a conclusion and discuss the result. So first, we will discuss the breast cancer, which is one of the most prevalent diseases around the world. According to a study by WHO, the World Health Organization, in the year 2020 alone, there are 2.3 million diagnoses of breast cancer around the globe. And not only is it very prevalent, there's also a challenge rising when treating it. So these cells are more and more resistant to apoptosis, which is programmed cell death triggered by the drugs we are currently having. And therefore, this would mean that the drugs that we're currently having are not so effective against these apoptosis resilient breast cancer cells. Therefore, scientists are looking for alternative treatments. And one of the alternatives is RF16662, which belongs to the family of nephroseridine compound. And this new compound is very interesting. Comparison to the other compound is that it would trigger necroptosis instead of apoptosis for cancer cells. And the necroptosis, it can effectively kill those apoptosis resistant cells, making it a potentially very effective compound against breast cancer cells. So to determine the effectiveness of this new compound against breast cancer cells, various methods are used. The first test to carry out is MTT cell viability assay. So this test tests how effective the new compound is at killing the breast cancer cells. The second test is DNA fragmentation analysis. In this analysis, we will determine that this drug will kill the breast cancer cells in the form of necroptosis instead of triggering other forms of cell death, such as apoptosis or necrosis. And the third test is MLKL, immunofluorescence test. And MLKL is a protein which indicates that the cell will undergo necroptosis. And the higher the MLKL level is, the more likely the cell will undergo necroptosis. And this is the test of the level of MLKL proteins to further reinforce if the new compound triggers necroptosis. The first test is MTT cell viability assay test. And so simply put, an assay was set up like this picture, in which the solid wells represent that only cell culture was put in here without addition of this new compound. And the checked wells shows that in these wells, cells was treated with various concentration of the new compound RF16662. And after incubation, we have plotted a graph of the new compound concentration against optic density, which reflects the concentration of viable cells. And we can see from this graph is that there is a linear relationship between the concentration of this compound in a log scale and the optic density. So this would reflect that as the new compound getting more concentrated, the cells are less and less viable. Therefore, this could indicate that this new compound is effective at killing those breast cancer cells. But in what way does it kill these cells? Is it via necroptosis, necrosis, apoptosis, or any other cell death pathways? It is yet to be determined. Therefore, a second test is carried out. This is the DNA fragmentation analysis. So during this analysis, the technique of DNA gel electrophoresis was used. So there are 4 lanes as the picture shows here. So in lane 1, it is the DNA ladder. And lane 2 is the DNA extracted from untreated cells. And in lane 3 is the DNA from cells treated with the new compound at 0.338 millimolar. And lane 4 is the DNA from cells treated with RF16662 at a bit higher concentration. And as we can see in lane 2 is that the DNA from the untreated cells remains integrity. It is still as a whole in comparison to lane 3 and the lane 4's DNA. And the DNA in lane 3 and lane 4 are fragmented. This is because that we can see that there are smears on lane 3 and lane 4, and those smears are to the left to the DNA bands in lane 2. This would prove that the DNA was into fragments. The fragmented DNA is a sign of necroptosis. Therefore, this test can prove that this cell undergoes necroptosis when affected by this compound. And the third test is MLKL, immunofluorescence test. And as I said earlier, MLKL is a protein that would indicate that the cell would undergo necroptosis. And from this graph, we can see that the cells that are treated with the new compound has more levels of MLKL protein than the cell that is untreated with the compound. And this would further reinforce the previous statement that the compound RF16662 can trigger necroptosis of the breast cancer cell. In conclusion, all these tests suggest that the new compound RF16662 is effective to kill breast cancer cells by triggering the necroptosis pathway. And so it is potentially an effective drug to treat breast cancer. However, the potential of this compound are yet to be fully explored. For example, this compound might also be effective to treat other types of cancer, such as colorectal cancer. So therefore, maybe scientists could also test this kind of compound on other types of cancer cells as well. And this is the end of my presentation. Thank you very much for listening.